27.
Mm-hmm.
Everything's still better than 27. Finally updated the dates.
That was unnecessary.
Ah,
The finally part was unnecessary.
work after class, or you got plans?
Good morning, everyone. Good morning. Hope all is well. Hope everyone's doing all right. Oh, got a few people trying to get in. I can get this.
So what you get is going to get a bit of rather than buying. I get a bit.
All right. Good morning, everyone. I think everybody's in now, but I hope everybody's doing great. Everybody is all right. Hopefully we can go ahead and get through C.2 today. If not, there's always Friday. Sorry for running late. Traffic got me. And then when I got in here, computer didn't want to start up. So, such is life sometimes, right? But it's all good. So C.2 is just the intro to functions. It starts off with the definition of a relation. Relation just any set of ordered pairs. So you see we have 3 ordered pairs right here. 1, 2, 3, 4, and 5, 6. And that's going to represent a relation for us. All right. Domain is going to be the set of all first components of your ordered pairs. So when I look at my ordered pairs of 1, 2, 3, 4, 5, 6, my domain will be 1, 3, and 5. The definition of relation. All right, your range is the set of all of the second components of your ordered pairs. So when your domain is 1, 3, 5, your range would be 2, 4, and 6.
Can you just reiterate what they are, please?
What you mean? What?
So the domain, okay, so that's the first number.
And each one of your ordered pairs.
Okay, the range is the second.
Mm-hmm.
So what is those little lines and alpha?
Just braces, just way,
Oh,
just braces. That's all, just to encapsulate. Instead of using parentheses, you will use braces. Yeah.
okay.
They don't carry no value, nothing like that.
Oh.
All right, everybody okay with domain? Let's go up on domain. All right, so the next thing that's in blue is just a comparison between domain and range, different ways you can identify what's your domain and range. We already talked about first versus second components of your ordered pair. That means your domain will be your X variables, your range will be your Y variables. By holding on to the range up top. Let's do that. Okay. And then here, could be an input versus your output, independent variable versus your dependent variable. Then also your horizontal axis versus your vertical axis. All of those are just different ways of identifying your domain versus your range. Letters could change, so that's why you don't want to always just lean on X versus Y. So you'll see as we go forward. Oops, as always, if I go up too far, somebody's copying, let me know. All right, so next we're looking at the definition of a function. A function is a relation in which the elements from the domain corresponds to exactly one element in the range. Which break you talking about? Thanksgiving break? Should be at Monday, unless y'all change. Huh? Yeah, so you said Thanksgiving break? So you leave Wednesday. I'm not, you know, leave Wednesday. Yeah, Wednesday, Thursday, Friday off, and you come back that Monday. For break period? That's you know what? I can't lie to you. I can't lie because last year they did do that. I forgot. So don't get me lying, but because that's new stuff, you know. December 1st. And you know what? I think you're right, because I think what they got us doing now is that the rest of the semester would be through Zoom. I think you're right. Yeah, this weird stuff we do now. But the good thing about our class is that we already got the Zoom link set up and stuff. It's not going to be new by the end of the semester. Some people, that's going to be a new thing for them, but we're good to go. So let's look at this first example. But I do know our final exams will be through Zoom anyway. So yeah, we probably just be operating that way now that I think about it. So we want to determine whether each relation is a function. We look at this example right here. Now remember, what we're going to be leaning on is the idea that the domain, each value in your domain corresponds to exactly one value in your range. So we have the ordered pairs of 1, 6, 2, 6, 3, 8, and 4, 9. And I'm going to erase this just so we can see how we set this up. Everybody done with that? Yeah, that's all that is. Okay, so you're going to create a mapping. In other words, all I'm saying is that you put one circle that represents your domain, other circle represents your range, write all of the numbers that's a part of your domain in the domain circle, write all the numbers that's a part of your range in the range circle. All right. So for our domain, those are the first numbers in each ordered pair. So that's 1, 2, 3, 4. For our range, that's the second number in each order pair. That's 6, 8, 9. Notice we don't write any repeated values. We just write that value one time. So before we go any further, is everybody clear with how we got to set it up? Like I said, domain circles 1, 2, 3, 4. Range circles 6, 8, 9. All right. So now What's going to decide whether it's a function or not is if each value in our domain goes to only one value in the range. All right. So you look at each value individually, and if you answer yes to each one of them, then yes, it's a function. So the number one, how many numbers does it go to? Just one. It goes to the number 6. The number 2, how many numbers? And we're talking about right here, 1, 6. Right? Looking at the second order pair, how many numbers does number 2 go to? Just one value. Now, it might go to the same number that 1 went to, but we're not talking about one no more. We're talking about the number 2. That only goes to one value, and that's 6. 3 goes to 8, and then 4 goes to 9. So since I can answer yes for all 4 of those numbers, then yes, it is a function. And like I said, it just so happens that the numbers 1 and 2 go to the same number, but individually they only go to one number. And so that means it represents a function. Determine whether each relation is a function. And making sure that each number in your domain goes to one value in the range. Mm-hmm. You might, when you see the next one, you'll see how what makes it not a function, and it'll make more sense. Yes. You jumping my notes, man. Come on. But yes, you're right. You're yeah, you can. Exactly. Just putting a visual on. I'll just make sure you understand, because I can assume everybody see it, and then we'll, everybody have questions. You know what I'm saying? So the fact that you can see it, that just means you're good with it. That's all. So, like I said, though, it's going to be more clear once I show you what's not a function. So is everybody okay with what we did here? All right, can I scroll up? Can I still copy in? All right, don't copy this stuff. That's somebody's asking questions. Okay. So now let's look at this next one. Like your classmate said, but you try to jump notes stuff. Nah. Well, okay, so let's look at the ordered pair 6, 1, 6, 2, 8, 3, 9, 4. All right. So create the same type of mapping. You have your domain, have your range, you have your values that are domain. We have 6, 8, and 9. Your range is 1, 2, 3, 4. So now you're going to take the same thought process and say, when I look at the number 6, does it go to only one number? 6 goes to 1, but it also goes to 2. So that means no, it's not a function. So you don't even have to evaluate the rest of them, because 6 goes to 1 and 6 goes to 2. That stops it from being a function. So once again, a function is when each value in your domain goes to only one value in your range. All right. Question on that before I give you some generic statements that you make about that might help you even see it a little better. Pretty good. So a couple generic statements that may help you see this a little better. Oh, what's going on here? So there can only be, or there can be a repeated value in your range, but no value can repeat in the domain. So what I mean by that, notice we have here the value repeated in your domain, so it's not a function. But when it repeated in your range, it was still a function. So you can look at it that way. Or the range can go to more than one value, but the domain can only go to one value. So once again, that's just generic ways of looking at it. They may help you, they may not, but just recognize that in the definition says your domain can only go to one value in the range. And that's what solidifies whether you have a function or not. Now hold on to the first statement. All right. So the vertical line test. Now, the vertical line test doesn't show up in C2, but it may show up later on, and it's relatively easy concept. So we're just gonna go ahead and talk about it since we're here. Anybody holding on to the range statement up there? All right. So vertical line test. If a vertical line touches or crosses a graph more than once, then the graph does not represent a function. So if you see a graph and you want to know if that represents a function or not, all you have to do is draw a vertical line through it. If it touches the graph more than once with that one vertical line, then it does not represent a function. All right. So last class we did graph linear equations. So if I were to take a vertical line, no matter where I draw the vertical line, it's only going to touch the linear equation once, so that line once. So that does represent a function. If I see a circle, draw a vertical line through the circle, it's going to touch it twice. So that circle does not represent a function. We also graphed a parabola last class, a parabola, which is this U shape. If you draw a vertical line through it, no matter where you draw the vertical lines, you're only going to touch it one time. So that represents a function. And then this shape right here, this graph right here, even though these first two lines, it only touches it once, this third line touches it 3 times. So that stops it from being a function. If when you draw a vertical line through it, it touches it more than once. So you see right here, the circle, a circle is not a function. See how I touch the graph? I mean, the vertical line touches it twice. The red line is your vertical line. That's your vertical line. That's the vertical line test. The green line is your graph. So here, the green line is this slanted line. That's your graph. Here, the circle is your graph. Here, the U shape is your graph. And then whatever the shape is, squiggly line is your graph. So if you had that graph, in other words, if you came to the graph and you just had that circle, if you want to determine if it represents a function, now you draw a vertical line through it. If it touches it more than once, which you see it does here, then that means it's not a function. Yeah, right here. Like when you draw a vertical line, it hits it twice.
Yeah.
But here it only hits it once, no matter where I draw the vertical line, it only hits the graph once. Okay. 3 different lines. Uh-huh. Yeah. Got a question? Yeah.
I'm just waiting. My question's always substitute.
Okay, okay. Almost finished. This is the last thing right here, function notation, and then we'll get substitute our functions. So function notation, y is equal to f of x. And that's what the f parentheses x, that's how you say that, f of x. So if you had g parentheses x, you would say g of x. That's just, now see, that ain't got nothing to do, that ain't no calculation. That's just how we talk, man. That's
I'm not used to the problem.
so that's how you say that, f of x. So all it says that you can substitute f of x in for y. And that's what we did here. Y is equal to 2x plus 1. That's the same thing as f of x is equal to 2x plus 1. So they're going to assume you know now that if you see y, and you know f of x is the same thing as y. They're the same. It's just that once you have f of x in there, that's actually your function being in function notation, what we call function notation.
So if we see this in a problem,
Mhm.
fx, so it's y.
Mhm. You wouldn't see them both unless something weird going on, which y'all not gonna have to see, but you wouldn't see them both in the same equation because one that f of x represents y represents f of x. So what function notation does for us is to be able to give us instructions without giving us a bunch of words. You see right here, you see find f of 3, or you could have just saw f of 3 and you would know what to do. In other words, what that means is I'm going to take 3. Notice how f of x and then f of 3, the 3 has been substituted in for x. So what that means is I'm going to take 3 and plug it into my function, wherever I see x. Now, f has to be defined first. So we already have our equation right here. 2x plus 1 is f of x. And that just means I'm going to plug 3 into that equation of 2x plus 1. And that's all function notation, you know. That's the main reason we use function notation, is to give instructions without giving a whole bunch of words. Also notice that this says f of 3 is equal to 7. The information that you could extract from that statement is that my ordered pair is 3, 3, 7. Because I put in 3, I got out 7. Remember we talked about domain versus range. One of the things you said that domain is input, range is output. So I inputted 3, I got out 7. Remember 3 was in for x. That means we got out 7. That means that's our y. So it's just another way of extracting information or being able to relate the information to what we already did. That 3 was our x. The 7 that we got out is our y. That means the order pair is 3, 7. Go up soon.
Okay.
Mm-hmm.
One more thing.
Mm-hmm.
Okay, one minute. I got.
All right. All right. So next example, last example, we have f of x is equal to 3x minus 5. G of x is equal to x squared plus 7x plus 2. And then h of r is equal to r cubed minus 3r plus 4. And they ask us to find f of 0, g of 1, and h of 2. So once again, the top one is our f function, the middle one is our g function, and the third one is our h function. And we're going to plug in accordingly. Mhm. Mhm. Now, when you're doing yours, you're not gonna get 3 at a time. You know, I'm just doing this so you can see that there's a distinction between what we're doing and stuff like that. You'll just get one problem per, one equation per. So if I have f of 0, I go to my f function and plug in 0. So that'd be 3 times 0 minus 5. 3 times 0 is 0 minus 5 is negative 5. Next one, G of 1. So you go to your G function and plug in 1 in each place that you see X. Notice there are 2 X's in there. So there's 1 squared plus 7 times 1 plus 2. 1 squared is 1, 7 times 1 is 7. So 1 plus 7 plus 2 will give us 2. You need given?
Yeah.
The word given.
Oh.
All I do is
Stop
stop.
it.
All I do is stop right there. All right, and then the last one, H of 2. So you're gonna take 2 and plug it in to the H equation. So that'd be 2 cubed minus 3 times 2 plus 4. 2 cubed is 2 times 2 times 2, which is 8. 3 times 2 is 6. So that'd be 8 minus 6 plus 4, and ultimately we get 6. Questions, make sure you're all right. Like I said, it's just a shorthand way to give us instructions on substitution and stuff. Substitution is specific equations. Questions? Any questions? So that's it for C2. So hopefully you guys saw the email that I sent there. I don't think I touched on it in the beginning because, like I said, I was running late, but we got a few seconds. I can go and do that. Send that email, and in the email, just let you know that 5th week grading is coming up. I already set that date in there, like one of your classmates mentions. I finally did it. I think I put it for 9/22. That should be a Sunday. So what's going to happen is to remind you of the process. And this process is not for everybody's class. I can't speak for teachers outside of this class. All I can speak for is how I'm going to do it. So on that Sunday, that deadline will pass. Then I have to tally up what grades are at that moment. Once I do that, then I will open up everything back up and you'll be able to work on it again if you miss some stuff. So now basically, what do you want your grade to say on 5th week grading? That's basically what it says. Because I'm telling you at this point, you should be here. And that's what I'm holding you accountable for. But I will once again give you the opportunity to make it up if you weren't able to get things done by that date. But for those who may have parents looking at your grades or may have scholarship committees looking at your grades, if they ask you, you can let them know that I will give you the opportunity to make it up. Also posted test 1 and your test 1 review. Don't forget your test 1 reviews are not mandatory, or any test reviews are not mandatory, but if you score 85 or better, I will add 5 points to that respective test. And then your test, you get 2 shots to get the best grade possible. If by some chance, something funky happened and you need an extra attempt for something messed up, all you do is ask for just a conversation. But you get 2 attempts without any type of conversation. All right, questions, concerns, comments before we close out today. Oh, let me say this as well. So what you're responsible for is B1, B2, B3, B4, C1 and C2, and then whatever quizzes, and then that test. So that block of content and test 1. So question before we close out today. Yes, ma'am.
I had a question on one of the before.
Okay. So, but that's not, so I'll take that before. Yeah. No, any class questions? Everybody good? The rest straight? Another problem? Okay. All right, I'm gonna take care of this. Everybody good? Anybody on Zoom have a question? Class happens? Everybody good? All right, if y'all are good, I'm good. Have a great day, not a great week because I'm gonna see y'all on Friday. And take care. Oh, next class, I will open up the floor for questions. If there are no questions, then I'm gonna go ahead and get into the next section. All right, y'all take care.